So hypernovas are significantly more dangerous than supernovas, but they're nowhere near as bad as gamma rays. But in some cases, you could argue that hypernovas are actually more dangerous than gamma rays because the thing with like novas and supernovas and hypernovas is that they can cover a wide radius. So, like for example, if a star blows up, basically what ends up happening is, and again, it really depends on the star cycle, what happens to it. If, from my understanding, if the star itself has more than 30 solar masses, and I know some people might be wondering what exactly that means. It's basically a big number. It's like there's a certain number times 10 to the 30th power. I'll do another video explaining what a solar mass is. But basically, what ends up happening is, as long as that number is greater than 30 solar masses, you're going to get a hypernova. And with a hypernova, it's kind of it's not like too far off from like if the star itself was to become a neutron star. It's kind of like the next step beyond that, except what ends up happening is the star blows up and it's like the same thing as supernova is, except it's like anywhere between like 5 to 50 times brighter, and it can leave even more mass behind. That stardust eventually just turns into something else, other nebulous clouds and all that. But the thing is, they can give off much more destruction, as well as I believe it can cover even more radius. Because, again, the more mass you have in a star, the bigger the star is. But what's also really interesting is you can have stars that can, like even the simplest stars that blow up, for example, you know, it can still be dangerous, if the planet itself still existed around its orbit, you know. And then there's the occasional, like, gamma rays, where, like, they're basically kind of hard to explain, but you basically have to consider the fact that when there's these certain rays that can give off, they call them gamma ray bursts. Not to get confused with like solar flares and all that. But apparently, what ends up happening is, you know, certain certain stars and other certain things that are flying in space have this ability where they can create this electromagnet field. And again, mind you, gamma ray bursts are significantly worse than hypernovas as far as the amount of radioactivity it gives off. As a matter of fact, just to give you an example, gamma rays are like if one was to hit the Earth, for example, it would just immediately wipe everything out. It's possible that it's kind of interesting like how it would happen. It doesn't necessarily mean it would destroy the planet. Like the planet would still exist, but it would like wipe out. It would just genetically change everything. Like it's like radioactivity. You can have so much radioactivity in one spot that it doesn't really change the. It doesn't change like the setting of the place. Like you could still go to it, but like you wouldn't be able. Like you could still see it. Like it's not like like leveled, like someone took an atomic bomb and just blew it up. No, it would still be there, but the area would be affected by radioactivity, and you probably wouldn't be able to live there. So it would basically it'd be like this planet. If the ozone layer, like that's what protects us from the OV lights and all that, or UV lights. Sorry. But basically, it's radioactivity that alters genetics, energy. So gamma rays basically just they do a lot of modifying rather, and it's a hazardous thing for the material because it would just wipe out. It basically just disintegrates anything it touches. But I guess if you had a big enough gamma ray, I guess it could destroy the Earth. Because what's really weird is, like, it's kind of one of those things you have to ask like a specific scientist, somebody who can really explain this to you. What's really interesting about these kind of things is like there's like you have like radius like it's like explosions can destroy things because it just incinerates everything. And then there's some things that it's not like an incineration that kills you, it's more of a radioactivity. So radioactivity is just something that alters, like, I'm trying to even think of the word. It just alters like things that we need to exist, or it can cause cancer. And like, I'll give you another example: cell phone radiation, or radio, radio wave frequencies can cause certain side effects to people with their hearing or their seeing, and it's strange, but it can happen though. Radioactivity and electromagnet fields. So again, it really depends on where you draw the line, but really I would say if you're talking about like something that can just wipe something clean off the face of existence, hypernovas are probably the way to go. But if we're talking about just radioactivity, gamma rays are significantly brighter, and they are significantly, like, they can just alter genetics and energy, physical properties, chemical bonds, like ions and subatomic particles, basically energy. So gamma rays can be significantly dangerous. While they cannot emit a wide radius like a supernova can, or a hypernova, it's just basically, you can think of it like a giant blast of light. And it's not as big, but then again, I guess it really depends on how much mass it gives off and how it's produced. If you really want to see what a gamma ray really looks like, they do have models on the internet of what they specifically do. And it's kind of interesting because just like hypernovas, they had never really been observed as much. It's really interesting to think that, scientists to this day are still trying to figure out how to replicate something that resembles a gamma ray. And it's really interesting to see like how dangerous those things can really become, because generally over time you could have something that could exist for years, like planets could exist for years, but then it's like something in space could just wipe it out because it collided with it, whether it was a rock, whether it was some sort of energy, whether it was some sort of just light particle, photons in this case. And who knows what dark matter is capable of doing if we could just figure out like what to do with it. I mean, you have like all these different elements. The main elements would be not just chemistry, but like you have like water, earth, wind, fire, and then you'd have like light and darkness, for example. So like light could be like like plasma, balls of heat, stars in this case, gamma rays included, and but darkness could be like like black holes and dark matter and dark energy. And it's like aside from black holes, it's like, well, what the heck are what can dark matter do? Dark matter can technically be like some sort of other radiation that we look at it and it's just nobody really knows like what it is, but it's more common than anything else in the universe. Dark matter and dark energy. It's just crazy to think like it's there, but it's like, what is it though? And even some of the smartest scientists in the world are still trying to figure out what the hell it is. Nobody knows.